Good morning. In these first two videos, we're going to talk about how to solve systems of equations, which is Unit 4, not Unit 5, and focus on solving systems of equations by graphing. So in this first video, we'll talk about graphing when the equations are in slope-intercept form, and then in the second video, we'll talk about how to graph when they are in standard form. In addition, we're also going to talk about special cases and kind of what happens, or what they look like on graphs. Okay, so a system of linear equations is a set of two or more linear equations containing two or more variables. In Algebra 1, we focus on two equations with two variables. So typically we have x and y, unless we're looking at an application problem. So we have two equations with two variables. And then a solution of a system of linear equations with two variables is an ordered pair that satisfies each equation in the system. So if an ordered pair is a solution, it will make both equations true. So that's really easy to see when you're looking at a graph. We're just looking at the point where the lines cross. There are three cases here that will happen when we graph a system of equations. The most common case is the one right here in the middle, where they cross at one point. Okay, this is when we have one solution. We're going to write our answers ordered pairs. So our solution is going to be -2, -8, because our ordered pair, or our point, is at -2, -8. The other two cases are when we end up having parallel lines, or we have the same line on top of itself. Okay, so for parallel lines, if the parallel lines are never going to cross, then I can't ever find a solution there. So we're going to write no solution. Okay. For this third case here, C, it only shows up as one line. What that means is every point on that line works because it hits both lines at the same place. What we say there is that there's infinitely many or infinite solutions. Okay. So here's a table that kind of breaks that down. If they're intersecting lines, we have exactly one. There's different slopes there. So you can find a point where they cross. They call that consistent and independent. Consistent and dependent, okay, is when you end up having coincident lines, or lines that end up on top of each other. They have the same slope and the same y-intercept. That is when we have infinitely many solutions, or infinite solutions. And then parallel lines never cross. We have the same slope, different y-intercepts. That is when we have no solution. Okay, so this one here is where we would have one point. Okay, we'd have an ordered pair x, y for a solution. This one is infinite solutions. This is no solution. Okay, so I'm going to leave this to you. Go ahead and hit pause. Do these two problems, find your solutions, and then when you're ready, go ahead and move on. So what we're going to do here is we're actually going to solve the system by graphing. We just reviewed graphing lines in slope-intercept form. So all you have to do is graph the first line, then graph the second line, and then identify your solution. So my first line here is y equals -x minus 3, or -1x minus 3. So I'm going to identify my slope in my y-intercept and go and plot those. So my y-intercept is at -3. My slope is -1 over 1. So from my intercept, I'm going to go down 1 over 1. Okay, now, it is extremely important that you have a straight line when you are doing this, because if you do not have a straight line, it will really mess up your answers. So I'm going to make sure I have a nice straight line here. I'm going to make it purple so we can remember it's with that first line. So we'll go purple here. Put some arrows at the end. We should be good. Okay, so there's our first line. Not too bad there. Okay, second line, switch colors here, is y equals 3/2 x plus 2. So my slope this time is 3/2. My y-intercept is 2. So I'm going to start at 2 and go up 3 over 2. Or, if I run out of room, remember I can switch that and I can make it -3 and -2. So I'm going to go down 3 and back 2. Okay, I'd like to have those 3 points because it helps me get a nice straight line, but definitely just be careful. like I said, if you don't have straight lines, it could mess up your answers. Okay, notice that my lines go all the way across the graph when I do this. It makes it easier to make sure you find the point where they cross, because if you don't make your line long enough, they might not cross, but that does not necessarily mean it's no solution. You only have no solution when they're parallel. Okay, so first one, we graph the first line. Second one, we graph the second line. Now we are going to find the point where they intersect, which is my actual answer. My actual answer is right here at the point -2, -1. Okay, so when you do this, that is actually what I'm going to be looking for there. Okay, there are 2 more here for you to try. When you finish, have them checked, and then you will get your homework so you can get some extra practice. Have a great day.